Hey everybody, it's time to get started here. We are probably gonna, I've got 474 up in the background right now, but we can get started on the project here. Who has project questions? We can get started on the project. So let's get the project downloaded here. So still growing the beard, so looking crazier than ever. So I'm gonna just close that out. This is 474. We were doing support vector machines. Really fun concept right here. So at the start of the 201 video yesterday, accidentally put that on there. So let me close that window. And let's pull up the Stat201 website. So stat201.utk.edu. Let's go check it out. So we should have everyone looking at the Stats1 webpage. I couldn't figure out how to make the pie chart. Now it might be, sorry about that, I updated the project. I maybe need to send an update. Jay, did you download it right away? Because there was an update and maybe I need to send it. It was like the first day I made this update. You might have downloaded it literally at the very start. So Jay, you might be looking at the error, which maybe I should send an update. So I'm very sorry about that. It's on version 1.3 because I made a typo. So sorry about that. You might have got caught by that. And it's my fault if that happened. So I think you might be talking about this right here. Are you talking about this question right here? So I think it said pie chart originally, but it should be histogram. Yeah, no, I realized, and I didn't think everyone had downloaded it. Maybe I'll send an announcement. So I need to put a mental note of that right now. It makes sense, yeah, because you will get a histogram, so it's complete typo. Sorry about that. Just writing the project, thinking about different distributions, and wait, it says histogram. Wait a minute here. No, you should get a bar chart. Oh my gosh, it's not a histogram, it's a bar chart. That's what I was thinking. Well, darn. Someone pointed it out to me and I was like, oh yeah. But no, it should be a bar chart. Well, we're going to version 1.4. So I was right. Hey, mine says histogram and box plot. So what it is, well, this one right here, let me just make sure my brain is not broken today. So what we have going on right here is this is proportions. So you're analyzing the test results by machine. So this is a bar chart. And let's just show this briefly right here. Well, I'll kind of show it because machine is going to be a categorical variable and test results are going to be categorical. So what we're going to do right here is we're going to go into jump and I'm going to go to some of the old project data. So I never want to do exactly the project on here. Like I never want to do exactly what's going on. So let's take a look and let's go into some older project data. Let's go to project 2 and this is project 2 data, but I want to point out that what we're doing right here is we're taking two categorical variables. So we have something like if someone was born in Tennessee and we have if they were in Greek life. So we're going to analyze distribution, and this is question number 2 basically, and you look at things like, let's look at born in Tennessee right here, and then let's look at the Greek life right here. So when we do this, we get the following. So let's stack this right here, and we have basically the same graphic. So I'm basically doing question number 2 right now. Does everyone see this right here? Now these are bar charts. I know they look like histograms. Jump has they make histograms look like this, they make bar charts look like this, but they're not histograms because they're not quantitative. So I see where my brain kind of flipped and someone was like, oh, it should be histograms. So I changed it and I was like, oh, it should be because we're using analyzed distribution, but analyzed distribution can also do histograms. So here we go. Here's a histogram by born in Tennessee with age. So these on the right are, on the left are histograms. I guess I could have said on the right are bar charts. And so on the right we have bar charts, and on the left we have histograms. So histograms are a quantitative measure of data, a univariate quantitative measure of data, and bar charts are a univariate categorical measure of data. So we have bar charts on the right here above me are bar charts, which this is what you should be making right here. You'll get these graphics. I know they look like the histograms because they're the same colors, but we can confirm that these are bar charts right here by going to Graph Builder, which will give us a similar thing but not the same output. And we have born in Tennessee, so let's put born in Tennessee on the bottom. That's going to be, we're doing Greek life, so we need to put that there. And then we need to put Greek life right here, and we need to click the bar option. So, well, the bar chart is, which one's the bar chart? I don't use this one a ton. There's a mosaic plot. Can we get stacked bar charts? Ooh, that's a weird stacked bar chart. Let's start over and let's do it the other way. So we need to put born in Tennessee. Which one did I put? So born in Tennessee, I think we'll go here. And then we will have Greek life over here. Now, I wouldn't suggest doing it this way. And then we can do this. Where's the button I clicked? I clicked this one. I don't like the way it looks. You'd have to like flip it, but you could make basically the same graphics I have over here. And this is why I wouldn't use this platform. But if you notice this graphic right here, you can see, well, it's actually the reverse of it. We'd have to flip the axes, but you're making bar charts again. So born in Tennessee should be on the X. Let's do that way. So born in Tennessee should be on the X, and then that's kind of cool right there. And then Greek life should be on the Y. That makes sense because Greek life is the thing we're analyzing here. And then we go here to this one. If you notice now, the graphics are the same. So these two things are those, and then these are these right here. So this confirms that we're using the graph builder to make the same thing, but I'll update it again. And I know it looks like a histogram, but it's not a histogram, it's a bar chart. And I think that's where my brain just jumped a moment. But does that make sense? You will be making a graphic. Jay, are you on track with making a graphic that looks just like this? Which you can make a pie chart of it. You just can't do it via analyze distribution. At least I don't know a really good way. You can make a pie chart of all of this by going to, so let's do this. We want to analyze whether people were born in Tennessee. So we'll see if there's questions in the chat. Let's do Greek life because that's what we do over here. We want to analyze Greek life, and we can make groups here on born in Tennessee. So let's go to groups, and then we could do pie charts. And so I don't like the way that looks right there. Same color, really? That's weird. So that's why I don't use Graph Builder that much. And I guess we could go to color, and we need to go to Greek life for color. So I'm just kind of playing around with this for the moment here, right here. I don't know why it's same color. That's why I wouldn't use it for that. So these are bar charts here. Are we supposed to make a histogram or pie chart? It's a bar chart. I'll update that. Let me update it right now, and I'll put it in there. Sorry about that. It should be bar chart. So you will be making the graphics that look just like, let me show you which one. You'll be making a graphic that looks just like this. Your graphics look very similar to this. I don't want to do the exact thing we're doing in the project, so I don't want to do exactly what you're doing. But does that make sense? And do you have graphics that look like this right here, Lauren and Jay? Did you get these sorts of graphics right here? And then I'll talk through kind of the other questions and do like similar things to it, and I won't really analyze your data. Yes, thank you. Awesome job, Lauren. So if you have these graphics, you've done it correctly. I know they kind of look like histograms. It's just that analyze distribution does the same thing. I put pie chart because I was kind of changing it up, but you can't really do a pie chart via analyze distribution. And then someone was like, shouldn't it be histograms? And I changed it. And my brain, there's so much going on. It's that my brain was like, wait a minute. And I was like, it's categorical. So I was right thinking we could change it to pie charts. It's just the analyze distribution platform doesn't have pie charts on it. So keep asking questions in the chat. What you'll notice is the red arrows have all your options and jumps. So let's close this output out because we're not going to get for question 2 anything that looks like that output right there. For question 2, we will get the following outputs. When you go to analyze distribution, you will get a bar chart. I'll update this here in a moment. I'll probably send an announcement just saying question 2 should be bar chart. So you should get output that looks like this. I mentioned it in today's video. And we go here and we can do things like test the probabilities, which will do a hypothesis test. This is testing the true proportion right here. And then we can do confidence intervals, which we're doing down here. If you notice the confidence intervals, you can select 90 and you get your confidence intervals. Now, if you change the graphic, it changes the way it looks. Now, something I want to point out, this is huge. Take a note on this. Whenever you're going to put your results into the project, use snipping tool or Command-Shift-4, but take exactly what you want. Like, if you're going to talk about the confidence intervals, then go to the part, and of course, don't put all the numbers in here, but maybe do it in parts like this. But put exactly what you want in there. So when you're doing the project, to make it look very nice and neat, always kind of look at how big it is and kind of look at the orientation of it. Be like, okay, is this about the right size I want? But if you notice, if I'm going to put my 2 confidence intervals in here, I'll probably talk about them afterwards. I'm going to go to the confidence interval output because that's all it wants. I'm going to put that right here. So we have all of this right here. I might even clean up the images a little bit. Looks like I did a pretty good snip on it. But a thing I think people don't even realize a lot of times is if I don't want this note computed using scores right there, if I don't want that, I can go to Format. Probably a lot of people know this. Crop right here. And then you pull on this little black tab right here. and then you simply click outside of it, and you've removed that area. Now I could try to make them both the same size. There's probably a quick trick to make them both the same size, but this is what I want to display. So I've got some really nice, good images right here, good size on them. Think about these things. We do take out points every once in a while if someone puts huge images or too small images, but you want to be like, does this look like the right size for my report? When you look at the results right here for the analyze the by, so let's go back. Something I don't want to do is there's no point in including, I want to show the difference between these. Here's a really bad screenshot, and I'll say why it's really bad. It's not a horrible screenshot. That might border on losing some points, but one, we're not going to talk about this stuff right now. Two, I'm going to show you a trick right here. Here's a big trick. A lot of people wonder if you have something selected inside of jump, there's a few ways to deselect it. On the Mac, you can go to the very top of the screen and you'll see a thing that says rows. Here it is on the PC. It's right there at the top of the window on the PC. At the Mac, it's at the very top of the screen. So if you're using a Mac right now and you have stuff selected you don't want selected, go to the very top of the screen. You'll see the same button I'm on right now. If you're on a PC, it's hidden in that blue window. Go to rows and go to clear row states. Now this will remove all colorings and markings that you have made, but it'll also remove anything you've selected. So I've unselected that data right there. I've deselected it so it's no longer highlighted. And then I'm going to go here and I'm going to redo my screenshot. And I'm going to go up here to the top and I'm going to go only to the things that I really care for. I only really care for this right here to be my screenshot. And this is a much better screenshot when you think about it now. Let's look at the two screenshots. I can even zoom out on this one or kind of make it smaller. That's what I meant to say. So I'm going to make that one smaller and takes up less space, only displays what I want to see really right there. So this is way too much info. It's got the confidence intervals and everything I don't need right now. So I would remove this one. And when I'm doing my report, which once again, don't leave the numbers in. When I'm doing my report, I'm really only going to have screenshots like this right here that show exactly what I want the user to see. So be thinking about these things like, what do you want the user to see? What information are you presenting to them? If you're only presenting a bar chart with the percentages on it and the counts, do that right there. Let's talk about what is in this bar chart, which is going to be very similar to what you're creating. My bar chart, which is not your bar chart, has here people, whether or not they were in Greek life. So we have, these are the people who are in Greek life, yes, and these are people who are not in Greek life, and these are people not born in Tennessee. And we see here that the people not born in Tennessee were more likely to be in Greek life. Don't we need to include percentages? Yes. And so guess what we have right here? Great question, Jay. The percentages are right here. So I believe this is what you're including. Let's look at question 1A. Include the graphics and interpret the percentages for the current and new machines. So when I look at this, I would say 47% of people not born in Tennessee were in Greek life, and 38% of people born in Tennessee were in Greek life. And we see here that there's kind of a higher probability that people will be in Greek life if they were not born in Tennessee, excuse me. The people who were not born in Tennessee, the probability that they were in Greek life was 47%. It's almost 50-50. It's a little less than 50, but it's kind of close. Does that make sense how to interpret this graphic and what these numbers mean right here, Jay? That you have, my graphic will be similar to yours, and these are the probs right here. Yep, the probs are what we're looking at. So the probs are, the 47% is this right here. You can also do, if you really want, this is not a bad idea, you can hover over these things and pin to it. Oh, it doesn't show the percentage. That's only the counts. I know once you see it, it's like, oh, that's simple. And that's the way it is. That's don't worry. I appreciate all questions, but you're like, oh, wait a minute. That's how we do it. So these are just the probabilities right here. And if you hover over stuff, usually it'll tell you what it is. I wish it would show it. There might be a way to... You can change the histogram colors. If you right-click, you get these options. Fill pattern. I've never tried these. That's weird. I don't approve. So, someone's going to do that now. I would not do that. Oh, how do I go back? There we go. Okay, good. We're back. So that has this question right here. And the main thing you're doing with this question then is making confidence intervals. And now everyone should know in my class the 3 conditions for confidence intervals. Does anyone have any idea on those? What's condition 1? How did you have to select your data? How did you have to select your data? What is the first condition? What is the first condition? Random, Jay, amazing job. Random. So the first thing you had to do in this project, which we didn't do today, but I'm just kind of showing each question as people ask me, nice job, Lauren, right there. A million points, both of you. So we do a random sample to start. So obviously that condition is met. Condition number 2 is 10%. So I'm doing a different question here myself. Looks like that I've sampled 548 students who are not from Tennessee, and I would say that that's less than 10% of all UT, like both of these. That's less than 10% of all Tennessee students, and this is less than 10% of all Tennessee students. So I'd say here the sample of 548 and 760 are less than 10% of all students. So you have to think of your sample size of 300 something and think, is your sample size of 300 less than 10% of all engines they will make? And here's a hint of how many engines they make a year. So there's the hint of how many engines they make a year, and then you have to think, is your sample size of 300 less than 10%? What do you guys think in the chat? Do you think your sample size of 300 something will be less than 10% of all engines they make this year? Do you think, what do you think? Or nah, or yeah, it definitely will be. So, and maybe even compute, say my sample size of this is way less. Yep, that's yep, definitely right there. 1,000,000 points, Julio and Lauren. So, and great answers in the chat. And I think Streamlabs, let's check Streamlabs real quick. See if Streamlabs is doing its thing. So, oh, what are rules? Points. There's rules in the chat now. I was looking into that. Like I can make a thing for rules, like be nice to everybody and all these things. So someone could ask like the rules in the chat and it could be like, be nice, don't say this or that. So I'm always looking into like new things we can do. But all the things are like commands you can put in the chat that will pop this up. Like when you do exclamation mark vote. Streamlabs not on? Streamlabs, you there? Have it on the background, right? Everyone can hear and see me, right? All of a sudden you guys are like, we can't see you, Brian. I'll be like, no. Don't tell me I broke Streamlabs again. Don't tell me I broke Streamlabs again. What other questions are there? Feel free to ask any questions on the project. Be like, Brian, I do not understand this question right here. Any question you guys want on the project. Well, maybe I broke it again. Be such a bummer. Maybe I have to have it started when I'm running it because I turned it off for a moment when I started the stream. Which other questions are there on the project? Question 3, whatever we are on. So all we have is the interpretation of the conf roles. Let's talk about the interpretation of the conf role here real briefly. I'm going to open up a new window right here. So let's do the interpretation of the conference role. And apparently I broke Streamlabs again, unless I shouldn't be doing an unlisted stream. Should just be a regular old stream. So Streamlabs, you've disappointed me. So let's talk about how to interpret a conference role. We should know our blanket interpretation right here. And I ask that you do this whenever you interpret a conference role, is you do your, histogram. Yeah, let's do that one next year, Julio. We'll do that one right after this one. So I am blank % confident that the true blank is contained in the interval blank to blank. So every time you do a conference role interpretation, here's what you need to be doing. So I need to look at my data now and interpret it this way with the conference role interpretation. So let's practice this. Let's do the I am blank % confident that the true blank is contained in the interval blank to blank. So let's give a look at this. You ready for this? We need our data. And I'm doing a different data set, remember. So I have to interpret one of these right here, and I'll just do one of these. So we're going to bring this down to here where we can see everything, and we're just going to put this right over here. So there's my conference role right here. We're talking about the people who were not born in Tennessee. If you remember, these are the not born in Tennessee people. And we're talking about the percent of people who are in Greek life. So if we're interpreting like the yes level, it'd be I am 90% confident, excuse me. I am 90% confident, because there's my 90% confidence, that the true proportion of people not born in Tennessee who take part in Greek life is contained in the interval 44.5 to 51.5. Does everyone see it right there? Follow through with me as I read this. I am 90% confident that the true proportion of people who are not born in Tennessee who get involved in Greek life is contained in the interval 44.5 to 51.5. If you notice, this second part right here is the hardest part for everybody because people need to realize you'll either say true proportion, true mean, or true difference between the means. So there's 3 things you could say right there. The true mean, the true proportion, the true difference between the means. So I always have people pause after true because what are we testing right here? We're testing the true proportion of people born in Greek life for those who are not born in Tennessee. So you just have to think, okay, what did we look at? We're looking at people not born in Tennessee and the true proportion of them who took part in Greek life. So because it's a categorical question, it's proportion. If it was quantitative, it would be mean. If we were comparing 2 groups, it'd be the true difference between 2 means. So does everyone make sense right here? I think we're going to go to the next question. Julio was on question 3 right here. And let's take a look. Question number 3 has us doing a actual histogram and box plot, an actual histogram and box plot, so we're actually there. So put machine, we have this. So machine is going to be the categorical variable, and engine life is going to be the quantitative variable. So let's look at a graphic we should get right here. This will not be your graphic, but it'll be similar. So please do not do what I'm doing. If you're watching this, I mean, you should do similar things, but I'm not going to do the project and give the answers to the project. I'm going to do very similar questions to it, and then I want you to kind of follow along. So I'm going to go to Analyze Distribution, I think it was. So we go to Analyze Distribution. We could do something like high school GPA. That's quantitative. And then we could do born in Tennessee, which is categorical. So you should have the quantitative variable up here and the categorical variable down there. We're going to go ahead to stack. Now what I'm going to do is I'm going to hold Control or Command on the Mac, and I'm going to go here to this arrow, and I'm going to go to Histogram Options, Count Axis. Now if you didn't get the count axis on both, you can go down here to the second one, go to Histogram Options, Count Axis. I just used a trick. You can also hold Control or Command and stretch this graphic and make both of them change the way you want them. So Command on a Mac or Control on a PC allows you to hold that button, and then you can make changes on both graphics. Any graphics that's the same type of graphic will change. So if I move this all the way up, the other graphic does the same. So I'm just holding down Command. If you can't see, Brian, oh no, can't raise the keyboard up. It's monitors on it. Monitors here, monitors there. So I have some pretty good looking graphics right here. I'm of course going to try to make them as exact as I want them, looking good. Now, one thing we should also do, I don't know if the question says this, but I'm going to do it anyways, is we should, hey, what's up, Walker? We're on question 3 right now, talking about how to make stacked histograms right here. We should go here, and we should go to uniform scaling, and we should go here and go to uniform scaling. Awesome, right there. Do we need to have a count axis on the X and the Y? Yeah, it should have a Y count axis and an X count axis. Do you have both of those right there, Lauren? So let me make sure it says all this right here. Make sure the histogram have count axis included. It doesn't say uniform scale, so I guess we can't take off if you don't do uniform scale, but it's a good idea. So do this, Lauren. Have your graphic open right here and click on this red arrow right here. So click on this red arrow and go to this option right here. So on the red arrow, you should have histogram options count axis. So see if you have that option right there, and that should bring up the count axis on the Y axis. Does that make sense? And do we have that right there? And we should be doing stacked histograms. Got it. Nice job. Now make sure it's on both of them. And then you can also click the uniform scale. We won't be taking off points for that. It's not in the project, but it's not a bad idea. So there we go. Put the machine, include the graphic, interpret the distributions in the new and current machine, make sure there's no count access. Or in horizontal format, have quantile statistics are included to the right. So yes. So once again, anytime you're asked to make something, you always have to include it. We've had people not include these screenshots, but since you're asked to make it, since you need the quantile summary statistics, all this stuff right here, you have to make sure that you include the screenshot. And I would go right here, and this is a rather large screenshot, but that's the way it goes sometimes. So I would include this screenshot right into here. So there we go right there. So there we go. And I'd make it about that size, and I'd kind of look at the sizing. I'll zoom out a lot of times and see how things are going. If you look, a lot of my graphics right now are of similar size, and if you look at the fonts, we're going about similar nature. And I'll clean it up at the end, but I'm kind of just getting my graphics as I go through this and do this. But they're very similar in font size and just graphic size. So having things similar is very good, and yeah. Okay, so we got our stacked histograms right here. Might make it a tiny bit bigger. There we go. And so we have right here, they want a certain amount. So if you look at this right here, I want someone in chat to tell me what this is in notation for 5 million points. What is this value right here in notation? Does anyone know what this value is in notation? Who knows what that value is in notation? I'm going to add new pens while you guys try to figure out what that is in notation. We're going to do... We got rainbow pen back. Let's do it. Whoa. There we go. We have rainbow pen. Wow. Who knows what that number is in notation? The company is interested in this value right here. They're interested in that value. So that value is a value they're going to see if they meet that condition. So they want to see if their engines last more than this time. So the goal is for the company to see if they last more than this amount of time. And think about this. This is quantitative data. So since this is quantitative data and we're testing that value, those are the big hints. So this is quantitative data and we're testing that value. So what is that? We always talk about marking notation. Whenever we see something, we should know what it is in notation because it kind of helps us. It gives us a mindset of what we'll be doing with it. Any ideas? Who knows in the chat what 3600 is? Any idea? Let's give them more hints. You ready? Here's another hint in the description right here. What is that in notation? Any guesses? I know we only probably have like 10 people watching, so it's only a few people can guess, but 5 million points. Does anyone know what it would be? What is that? Well, that's a condition we'll be doing later on. So it says check the condition. Yes, Julio, 5 million points right there. That is mu naught. That is the tested value. Amazing work. That is mu naught. That is mu naught right there. Yep, and it'll be mu naught because that is the tested value. No, don't worry. You're doing the conditions. Walker, you are right that the three conditions here will be random, 10%, and we will actually probably do nearly normal because large enough n is part of the nearly normal now. So we'll do nearly normal, but we could do it by way of large enough n. So we kind of need to talk about these. If you notice my distributions, I have a huge sample size. So if you were to do the conditions right here, these are only a little bit skewed. So we do see a big outlier right there. But there's only a little bit of skew, like moderate skew. And my sample size is way larger than 25 and way larger than 100. So passing the nearly normal by way of large enough n. Because when you do the nearly normal has, so the nearly normal is the condition. So let's write nearly normal. Actually, let me do a brand new sheet for this because this is a big topic a lot of people get confused on. I've gotten a lot of emails on it lately because it's like, what's the difference between the nearly normal and the large enough n? So nearly normal. So the nearly normal condition has 4 ways that we can check it. The 4 ways we can check the nearly normal are, and they kind of go up in magnitude and ability as you go higher and higher. The first way, which I would not suggest, which we don't really do, is the look at it method. So we'll go right here with way number 1. Oof, I made that pen way too big. So we'll go here. We're going space pen is back. Way number 1 is the look at it method, which is you just look at the histogram. So if you look at the histogram and it looks normal, it's good. And so we need a green pen now. And so if you look at the histogram and it looks normal, it's good. If the histogram looks skewed, it's bad. I would not suggest this method. It's a little too elementary and we have much better methods. Way number 2 in the nearly normal method is the normal quantile plot. The normal quantile plot will look straight if it's normal, and this is what we did in chapter 5, and will look bent if it's not normal. So these are the boundaries for it, which I cannot draw this morning. So the boundaries for the normal quantile plot, and then let's do the normal quantile plot. It'll look straight, and it'll follow this. The straighter it is, the better, because it's following the normal. And then it'll look bent if it's not normal. So we've got, once again, right here, we're good here, and we're bad here. We next have a goodness of fit test. The goodness of fit test will have a, if it's good, it'll have a high p-value. So we'll write here a value like 0.40. And if it's low, it fails the goodness of fit test. That's a very quick summary of that. So that's bad. Do the green check first. There we go. It's good. And that's bad. And then last but not least, we have the, guess what? You said it just a moment ago. We have the large enough n condition. So in the large enough n, this is the complex one, where we have the ways of doing it where we can go, if it's normal, the sample size needs to be 1, but we really can't tell the shape of it with a sample size of 1. And if it's skewed, which that's heavily skewed, if it's skewed, then it needs to have a sample size. We'll do skewed this way. I cannot draw this morning. There we go, there we go. If it's skewed, it needs to have 25. And if it's heavily skewed, so now I'll do a heavily skewed one, it needs to have a sample size of at least 100. So this is a very, very quick review. But we have all the ways that it works right here. You can't really tell the shape with one observation. That's why we oftentimes use it more for the sampling distribution of the sample mean when we know the shape of the parent population. But if we have a sample, we can still use large enough n to say that, yes, we would assume that the distribution of the mean will be nearly normal by way of knowing what we know from one sample. I know it's a little bit confusing, but the nearly normal is a very complex thing because we're trying to gauge the normality of it. And so this is what we have going on right here. Does that make sense to everybody? And why we probably pass for ours? I could do a few things right here. So I'll show this over here. I would not use way number 1. Let me put a big X on way number 1. That is not really good statistics. Just look at someone and say, yeah, that looks normal to me. It's not the best. I wouldn't do that. So way number 1, which people do often use, is not really good statistics in my mind. What you could do is you could go here to normal probability plot, and you look, this looks fairly straight. Do you see how we said it should look fairly straight? I only see problems down here where the skew is, and then we go here to the other normal probability plot, and we see, wow, you see that mega outlier right there? So we do see issues with this point down here that it goes way off the line of what should be normal. Now we could go and we'll probably fail the goodness of fit test. I'd be shocked if we pass it. The goodness of fit test, which was way number 3, is found under here under normal. Sorry, we got so much output now. We go up here to this arrow and we go to goodness of fit. And as I thought, we failed the goodness of fit test. This has to do with statistical power, which is something we talked about. Due to the large sample size, we're able to reject the null more often because basically nothing is normal. That's what you find out in statistics. And so we could do the same thing here. This one's probably even worse. We go here to the goodness of fit, or continuous fit. Where's my continuous fit? Fit the normal curve on it. So it puts a normal curve. We go here to the goodness of fit test, and of course we fail it because the other one failed and this one looks worse. And what's funny, I'm going to throw a 10 million point question. Does anyone see on the goodness of fit test, what is the test statistic, like the Z or the T? For 10 million points, does anyone notice on the goodness of fit, it has a test statistic like a T or a Z, but it's a very, very different test statistic. But what is the test statistic for the goodness of fit? Like, what does it use to do its test statistic? Like, we usually compute a Z or a T. What does the goodness of fit compute to do its test statistic? Look at the output and see if you notice the test statistic it uses to do the goodness of fit. Does anyone notice for 10 million points? I'm not asking big, crazy questions, but it gets you in the idea of statistics that we need this test statistic to standardize what we're looking at, and then we could compare it. I'll probably give this answer because I don't know if anyone sees it. But what is the test statistic on the goodness of fit? A lot of times we've been using Z's or T's, but this one doesn't use a Z or a T. It uses something vastly. Yes, Walker, you got it, because this first letter of your name, you got it, 10 million points. The test statistic for the goodness of fit test is a W. So you notice right here, you've got prob less than W. So that tells you that this is the p-value, because a lot of times we see prob less than Z or prob greater than Z. So this is the p-value. And if you notice there, if you can read the text, it's very small, but it is saying the p-value right there. And it actually gives you the decimals on the p-value. So the Shapiro-Wilk goodness of fit test does this. There's the omnibus, there's other goodness of fits. So that's a little aside on that, but let's go back to the project now. We've got interpretations right here. If you notice, it says we needed to test 3600. So how do we test that value? We just talked about the conditions right now, but how do we test the value of 3600? Well, once again, let's pull up another thing here. I kind of made a mess of that output. So we're going to do high school GPA by whether or not somebody has broken a bone. And if you notice here, whoops, that's not where we're going to do it. We're going to go to distribution. We're going to do high school GPA by whether someone has broken a bone. And here we are right here. We're going to stack it. We're just remaking these. We're going to make the graphic a little bit bigger by holding controller command. We're going to hold controller command. We're going to go here. We're going to go to count axes. Remember, you can pause the video or rewind if I go too fast. And then you go here, uniform scale, and go here, uniform scale. Okay. So now if I want to test a value, like let's say I were to test 3.7. So if I were to test 3.7, let's take a look at this right here. 3.7 is what I want to test. We are on part 3. We're doing the stacked histograms, Isabel. And feel free to ask a question, rewind the video, and feel free to ask any question. Good to have you here, Isabel. So I'm going to go here to the red arrow, and I'm going to go to test mean. Does everyone see that? I'm going to go right here to test mean. And under the test mean, it's going to allow me to put in a value. Now, are we going to do a Z test or a T test? When we do the means, we do T's. So when we do the means, we do T's. Hey, good to see you, Tracy. So remember for yours, and once again, good to see you, Melissa, we're testing a different value for yours. I'm just making up a value to test. Now, I want people to think about this for a moment. I want somebody to I'm going to give you a totally different value to test. Hey, everybody. So I want you to look at this value right here, the standard error, and I want you to think about the value of 3.734. So 3.734. And I believe the t-score for this, when I test this, if I did the math correctly in my head, should be right about -1. So it should be about -1. Let's find out. Did I do it right? It's 1. Sorry, my brain broke. It should have been 1. I did -1. It should be 1. Because the mean is 1 higher than that. Got it. Okay. So how did I know it would be 1, or I did it wrong in my head? I just flipped the y hat minus mu naught. We are on currently, we're talking about this part right here. We're on question 3. Question 3, and we pointed out that this is mu naught right here, which is the tested value. So we've got the tested value right here. So whenever you're doing this test right here, and feel free to ask any questions in the chat, be like, Brian, I don't understand this part, or go back to this. When you test a value, you go to test mean, and you enter that value in, and we've identified the value. Let's put it over here so people can see. We've identified that that value here is mu naught. Now I'm doing it a different way. I'm not doing your guys' project. I'm doing different questions, kind of just making it up as I go, because that's what the project basically is. So you could test any value you want right here by going to this arrow and going to test the mean. And this will do the equation y bar minus mu naught over s over square root of n. So what you'll notice is s over square root of n is just the standard error of the mean. Let me write a few things on this output right here. I think we have it. So let me go into this output and put notation, because this will be huge for the test. So what you need to know, you should know what all this is in output right here. So it's important to know your output right here, that this is y bar, this is s, this is standard error of y bar, that's the confidence interval, and that's technically lowercase n. So if you notice, excuse me, if you notice that this is everything you've been doing lately, because if you have y bar minus mu naught, which we just identified, standard error of y bar, just right here, I get stuck on how to find the conclusions on the homework and the quizzes. The conclusions, which conclusions? Like on a question, like how to, like what it means? I could go back. We could do that after this right here. I could probably do that in like after 11. People can keep asking questions on the project, and then we can do that. Just the ends. Yeah, we could do that here in just a moment. That sounds like a good idea. So yeah, anytime. No, if no one asks questions on the project, I'll go back and do that. So one thing we need to do is we need to write the null and alternative. Well, what did we do? We identified that this is mu naught. Who here knows what we should put for this null? Who here can put it? Well, it'll be in the video then. Let's talk about how to write a null alternative. Maybe people watching the video have not been practicing. Is the intro in the project the same format as the other projects? Yeah, let's talk about that next. After I finish question 3, I'll go back and I'll talk about the intro. So Melissa, let's do that next here. So I'll finish this part, then we'll go back and talk about that. So what you need to do is you always need to put your null and hypothesis like this. That'll be what you'll always write for any of them. Now, there'll be one, I think we'll do it next week, that'll change the mold. It'll break the mold of how we write these. But as of right now, we have the constant format, but the last one we do is very easy to do. It'll be very easy format, not too bad, I promise. And it'll just be x is independent of y, x is not independent of y. But it'll change the format of how we write these. And so right here, we have the first part, the second part, and the third part. First part, second part, third part. This is how we always know how to write our nulls and alternatives. I bet Tracy, you know this. Tracy, what goes right here every time? What goes right there every time? I bet you know that one like this. You're like, got that. What goes right there every time? Hey, Andrew. Oh, good luck with your interview. Hope it went well. You got it, Tracy. You are right. See, you know this. I'll see people make mistakes on that one. They won't put the equal sign there, but that one is always the equal sign. The null always has the equal sign. So the bottom one can have the other signs, which we choose from this, this, or this. So those are the ones we choose from for it. But we want to see, I think, that it lasts more than a certain amount. So you'll have to pick the right one right there. Now, so you'll pick one of those signs for here. I guess we could just leave those in here. But do not write, I'm going to see someone write this whole thing in. This is not the answer to this part. It's just how to do it. So next, and Tracy's right in the chat. I know you're fine. You can say it. Oh, they'll have to see that. They'll be like, oh, okay. And then here, we need to put a few different symbols, possibly. We could put P, we could put mu, or we could put mu1 minus mu2. And here we will put the same symbol. So whatever you put in part 1, you will put in part 1. So if I choose mu, hint, 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 I will put mu down below also. If I were to choose mu1 minus mu2, I'd put that down below also. If I put p here, I'd put p also. You said more than, yeah, it goes eat the bigger one. Exactly. Greater than, yeah, it eats the bigger one. That everyone learns that. You just put the teeth on it, and it's like the bigger one gets eaten. I think it's such a great way of learning it, and everyone should know that. And so here, to complement those on the other side of it, not like literal complements of, so we put right here, and I think that's what we resonate with, is you remember those things. You remember how people teach you a certain way. So if I were to put, let's make this as clear as possible. This is literally a whole review of writing nulls and alternatives. Like this is 3 out of 4 times the way we write the nulls and alternatives for the class. So this is a whole review of all the nulls and alternatives in our class. Does that make sense? This is a mega review right here. So if you put P for part 1, you will literally put P in both of part 1s, which means you will put P naught over here. If you put mu for part 1, you will put mu naught over here for part 3 in both spots. Like don't put, some people do this, they put mu naught and then they put y bar. No, there's no y bar in this, because y bar is the sample, so don't do that. And if you put mu1 minus mu2 for part 1, you will do that the same for part 3. Exactly. So this right here is a huge mega note on everything. It's like a huge thing. But last but not least, I should mention this. Let's add in the one last note here, because we're kind of just taking notes and making sure we know how to do everything. The last note I could possibly give you is the following. There is one more time we will do nulls and alternatives, and it'll break the mold. The only other time we will do nulls and alternatives, which is coming up here very soon, is we will write the following. You will write x is independent of y, and you also write the alternative, can't think, x is not independent. And so this right here is all your notes on how to write every null and every alternative, and you will use this one right here for the chi-squared test of independence. This is the chi-squared test of independence. I'm trying to think if it's on this. I think it is at the end of this project, which we'll be doing very soon here. But this is the chi-squared test of independence. I think we'll be doing it on Tuesday, which is right near the end of when the project's due, hence why the project's got to be at the end of the semester. But these are every single null and alternative. So this is the null and alternative for when you're doing one proportion. This is the null and alternative for one mean. This is the null and alternative for two means. And this is the null and alternative for the chi-squared test of independence. Was all the checked? Yep, I moved them back, Melissa, so that way they're one day after every class. So that way we have the video up and people can work and watch the video. So it's as far back as I will push them. They will not be pushed back anymore. So this is it for them. It looks like my Pearson's under control. I know we've had craziness with them being moved back, but I saw that some people didn't complete them and I was like, no. And I'm just like, okay, this is the last. Because I realized that if I do the video, then people kind of have to like that night work and watch the video. So I was like, okay, if I do the video like after class, then people can have at least that night and the next day to do it. And I was like, okay, I think we'll have better success. So I was kind of reevaluating and I was like, okay, I'll give one more day. You're welcome. You're welcome, Melissa. I'm always trying to think like, what is the best way? And then I start to second guess myself. I'm like, okay, I'll move it back. I'll do this or that. And so there is what's called tools and techniques, Tracy. And I think, so there's what's called tools and techniques, and we'll just kind of ask you questions like, here's a tools and techniques question. If we want to analyze height versus weight, what kind of graphic could we make to visualize that? If we want to analyze height versus weight, what kind of graphic could we make to visualize that? Any ideas on what graphic we could make to visualize that? What graphic could we make to visualize that? Careful. Bar charts and histograms really only cover one variable. Bar charts would be categorical. Scatterplot, there we go. If we want to analyze someone's favorite ice cream flavor, what graphic could we make to analyze that? Right, Don, scatterplot. So if we want to analyze ice cream flavor, what kind of graphic could we make? favorite ice cream flavor. We ask people, so think about the answers to it. It would be like Rocky Road or like cookie dough. So if you have answers like Rocky Road, cookie dough, so, well, there could be more. There could be like chocolate, strawberry, Rocky Road, cookie dough. So you just ask people, what's your favorite ice cream flavor? What graphic could you make to analyze that? And these are the kind of questions we ask for the tools and techniques. Any ideas on the graphics for that? How about a... we wouldn't really use a decision tree. How about a pie chart, a bar chart? Remember, you make a bar chart of your favorite pies and a pie chart of your favorite bars. So here's the best way to handle those things. Pie chart, there we go. Mosaic would be 2 categorical variables. So mosaic would be like, let's look at class level and favorite ice cream flavor. So class level is categorical, and then decision tree would be used for lots of variables. Like a decision tree question would be like, I'll come up with a fake decision tree question where that's the answer to the tools and techniques. It'd be like, a company is looking to see why their consumers purchase certain products. They've collected 50 variables on their consumers and want some way to analyze these variables to figure out why customers are making purchases. So decision trees, you dump in all your variables. So that would be like a decision tree one where you have like a lot of variables and you're trying to explain one of them. So that's kind of a classic way to write a decision tree question. Pie charts are always categorical. Mosaic would be 2 categorical variables. And so the best thing to do in any question is identify like what information you have. Like, okay, in the first one, we have 2 quantitative variables. Q, straight enough, no outliers. That's regression with scatter plots. In the second one, we're just analyzing 1 categorical variable, so we could make it into a pie chart or a bar chart. Because remember, you can make a bar chart of your pies and a pie chart of your bars. You could also make a Pareto from it, but we don't talk about Paretos that much. A Pareto is the special case bar chart that's been put in order. Well, I think we basically done, I didn't do the actual statistical test, but I could go back to it. Let's go back and look at the actual statistical test, and then let's talk about the opening here. So, yeah, pie charts are really not recommended. I agree. Million points, Melissa, right there. Pie charts are generally frowned upon. They're just not that great of an easy of a graphic to read. So we are not big fans of pie charts. Some people like them, but I'm not a fan of pie charts. So we have right here the statistical test. And so I tested a certain value, and if I wanted to see if it's greater than this value, here's my p-value. So here is the p-value for the, here's the p-value for the greater than test. Let's pull this in. So if I were to test a certain value, and I'm just going to take this graphic right here, and I'm going to bring it in and put it right here. Now, these are not the graphics, obviously. I'm doing different tests. That's way too large of a graphic. Always make sure to kind of look at it in scale, be like, how's everything looking, similar in size? I mean, you don't have to do what I'm doing. Like, I'm just perfectionist at this stuff. Did I just hit backwards? I did. Undo all my good work. So I'm going to center it and all that good stuff. And so it's looking about similar in size to me, so I think I'm good. So that's pretty good right there for where it should be at. And when you look at this right here, let's take a look what the results show. Here is the value I hypothesized. So this value right here is going to be mu naught. That is my mu naught value. The actual estimate is y bar. This is the degrees of freedom, so this is n minus 1. So I can actually tell the sample size on this. The sample size was 638, and so that is the degrees of freedom. Here's the standard deviation, which is S. I don't get the standard error here. I don't know why they don't report that. It would seem like they would if we're doing tests on the mean. And then there's the p-value for the does not equals test. There's the p-value for the greater than test, the p-value for the less than test, and here's the t-statistic. So there's all your output marked right here so we can see what's going on. But I want mine to be perfect too. Yes, that's the best way. Get 107. That's what I want people to get. But what do we see right here? Looking at this p-value right here, so I don't have my thin highlighter. Let me get that back right here. No, I'll just do a regular one. So we have probability greater than is this one. And if you look at that, I purposely chose one that'd be close to 1 because I wanted the p-value to be about 16%. I wanted us to be able to basically guess the p-value on this. And so, yeah, it's a very large p-value, above 0.05, and we would fail to reject the null. So since the p-value is high here, we just let it fly, and we fail to reject the null. We do not have evidence for your alternative here. Can you do a step-by-step on how to get all the graph pictures? I know there's a video on it, but yeah, which one are you wondering about? Which one? We did a few earlier, but which one are you wondering about with any of the graphics right here? Like, you can be like, question this. I can go back to the opening if you want right here, because we already did the statistical test here. But number 4, yeah, let's do number 4. Great question, Melissa, right there. Question number 4. Let's do it. So everyone, there we go. Question 4. From the Excel version of your random sample, use the calculate summary statistics. Awesome. Okay. So unfortunately, you'll only be able to see me be able to do the PC version right here of doing this, but let's do it. So this is the PC way of doing it. It is in a video on how to do the Mac version. So I need to go here to File, and on the PC I have to go to, I think, Save As. On a Mac, there's the Export button. So I have to know. Oh, everyone's so happy in the chat. I have to use Export on the Mac, and on PC I have to use Save As. If you're confused, I do have a video on it that shows you how to export this, but it's in the playlist, and you have to click down here on the PC, and you have to go to CSV. So you have to export the CSV file right here, and let's go ahead and do this. This exports as CSV. We click yes, and now it opens inside of Excel. So once again, this is the PC way of doing it. On the Mac, you will see File, Export, and then you'll click to export as a CSV. Are you on that part, Melissa? Do you have everything fine right there? How's it look right there with that? Oh, that's so good. You guys, yeah. Melissa sat right over there, and Tracy sat over there. So, like, I miss seeing everyone. It's just, like, it's such a bummer. It's still a great semester. Like, I'm still so proud of all my classes, but, you know, oh, that's awesome. Do you guys work at the same spot? That's so cool. I'm glad you guys still get to see each other. I mean, working is, you know, hey, essential workers, yay. Are you in the healthcare industry also, Tracy? So, are you doing nursing, or because so many things? I was a customer. Oh, yeah, okay. So, I'll leave it on there. So, human resource, cool. Let's go here and let's see if I have everything I need. I think I don't have on what I need, so I have to edit. We need to go to options, and we need to go to add-ins, and there is a video for this too. Excel add-ins, go. Analytics tool pack, there we go. And I might have to reset it because it looks like it didn't add it. So I did click to add there it is. It's right there. So the data analysis tool pack is on right now. Oh, you work to go. Oh, cool. So that is, yeah, I know what people are doing, because I know like it's interesting. Like, I usually know a lot of like the nursing majors and stuff. And it's so cool that I like that we have nursing, because nursing to me is like so involved in analytics. Like, to me, it's like they're like major things that go together, like analytics, making analytical decisions. Went to school for dental assistant. Oh, cool. Yeah, I just went to the dentist a little while ago. So let's go here. Oh, you can make histograms in here. Never tried that. So you can do the test and all these different things in Excel, and we want to go to descriptive statistics right here. And so this is the window we want. So is everyone at this point right here? Your kids have really good teeth. That's awesome. I try. I was so bad at brushing my teeth when I was a kid. I mean, I think every kid is, but I don't know. My brother and sister did way better than me. They got a higher score. Is everyone on this part right here? Do we have all of the... is everyone on this step? I don't even know what I clicked. Input range. So flossing is hard. I know, and you should floss. Everybody should be flossing. So what we should do is we should go over here and click all the data. So there we go. I think I have it all clicked now. I think I hit Control or Command A. So I got all the data. You actually don't need to do that. Let me not do that. It's actually a very bad idea. What you want to do is you want to click the variable you want. This is going to do a crazy bit of output. We're supposed to be analyzing right here a quantitative variable. So let's say I want to analyze something like this. I'll just click the column right here. So everyone see what I'm doing? I'm just clicking the top of the column, like weekly hours of something right here. This is, oh, should show me what it is, but that is weekly. Can't expand the column. Can I do it? Nope, can't do it. So this one is nightly hours sleep right here. So we have this right here, or we could do like longest hours awake. And so all we're doing is clicking a column, and it's putting this column right here. We have a label in the first row, so we need to click that. What I'm going to do is I'm going to put it into a new worksheet. I like that right there. I'm going to get the summary statistics. I'm going to get a confidence interval, and then I'm going to click OK. And here we are. How's everything look right there, Melissa? Did you get through all those parts that I just did? Does everything I did right there make complete sense? They're at 5 to 7 on Tuesday, Thursday, and then 10 to 12 on Monday, Wednesday. So 5 to 7, Tuesday, Thursday. Oh, and The stat lab, did Connor send me his times? I think they're posted in an announcement I sent out. So Connor is probably doing his regular times, and so is Livia. So check the announcements I sent out, and I'll maybe send a reminder. Email me after this, but Connor will also be doing that, and so he's been doing great, and so is Livia. So, and I'm so glad we've kept them on because they're doing excellent work. So we're going to click right here on this right here, and we're going to click on this, and we're going to zoom in on it. Is this... Yeah, Connor was there. Connor's such a great guy. And so is Livia. I mean, not a guy, Livia's a girl, but they're both great. And so all that good stuff right here. I'm just doing some cleaning up of this, yeah, Connor's excellent. I try to tell people how awesome they are, and I think they think I'm just saying that, but you know, we've got a lot of really great students who are really helping out, working very hard and everything. Connor could be on from 3 to 8. Yeah, tell Connor that's great. Tell Connor from 3 to 8 works. So yeah, Andrew and Connor know each other. Connor, I was talking about how awesome he is, both him and Livia. So definitely saying that they're some of our best. So is Andrew. Andrew's amazing. So I'm just color coding all this right now for fun of it. Gotta make these graphics look great right here. That's our goal. Good looking graphics. So we want graphics to look great. Andrew's doing an amazing job at 320 right now. So we're gonna make this right here, thick borders. I'm gonna go down here, click the borders here. Oh no, we have to go back. We have to go to the all borders, and then we have to go to the full borders, and we're gonna go to full borders on this. There we go. And I might actually copy this because I want to take a better screenshot of it. Expand this out, and there we go. And that looks pretty good to me right here. Now I might even do this. I might even go down to here to this one and make it the highlighted one. I'll explain why here in a moment. I think this is what I do in my other output. I could do that. So I think this looks pretty good right here. This looks like, nah, you don't have to, but I like to. This is, I think, especially if you want to show what you're talking about, this right here, let's put some notes on it. The following things, can I draw on this? I should be able to draw in Excel. Awesome, because it's a Microsoft product. This is Y bar. This is the margin of error. This is the sample size. This is the sum, so that'd be, you know, like a sigma thing, which we don't even talk about that much. We got the max, we got the min, we got the range, we got the skewness, the kurtosis, which is kind of peakedness. We got the sample variance, which is standard deviation squared. So this is S squared. We got the mode, which is the most common. We got the median, which is the middle value, and we got the standard error, which is the SE Y bar. So here's all the notation we could possibly write on this. Just understanding what things are and how we use them. We don't really use the sum of all the observations in our class. The mode, the most common. The standard deviation is S. The variance is S squared. So it's the sample variance, or else if it was true standard deviation, it'd be sigma. And if it was true true variance, it'd be sigma squared. So these are population. We could write mu right here. There's no standard error for that. And then this right here would be capital N. So just doing a quick little notes right here on the difference between the population, and I can't zoom out. So we have different notes right here on the screen right now versus these are sample and these are population. Now, everything in here is for a sample, but I just put the population notes for the heck of it, just to kind of be like, okay, here's the population parameters so we can see them. So you can see here that the sample mean is Y bar, the true population mean is mu, the standard error of the sample mean, which we don't really have a standard error of the population mean because you wouldn't have uncertainty in it. And then we have sample standard deviation, true standard deviation. What did you write by the sum? That's just a sigma right there. I'll write it in bigger. That's like the sum of all the y's. I should put the sum of all the y's. So it'd just be the sum of all the observations because y is an observation. So we've got just so it's just a thing on the notation. You've got Y bar, which is the sample mean. You've got Y, which is the observation. And then earlier chapter, we had Y hat, which is the predicted, which we use in regression. So we have here the mean of the Y values, a Y value, and the predicted for a y value, or the estimated y value. So it's just a little review of notation right there, but you guys know I'm huge on notation, that if you can kind of read it as what it is, it's just saying the predicted value of y or the estimated value of y by an equation. That's the last one. But there is no y hat inside of this one. There's just y bar, and then every observation would be a y. Like a value of y would be Brian's height is 75 inches. The y hat would be, we predict Brian is 6'1". The y bar would be the mean of guys' heights is 5'11". So y bar is the mean, and y is an observation, like a singular observation, and y hat is a prediction for someone. So those are the small differences right there, just between notation. What other questions are there? We could go back and talk about the opening, Melissa, if you like, and kind of make sure everyone knows what's on track for that. I think that'd be a really good thing to do, is talk about the opening right here. To be like, does everyone know what to do for the opening? Do you have this output pretty well right here and understand what it's saying to you? I haven't answered. Yep. So Tracy wants to do that, but I think we should understand at least how to handle this output and what everything means. Because I didn't say what the answer is to this question, but I kind of highlighted some stuff and kind of told you what exactly it is, to be like, so far, yes, awesome. We can come back to this if you want, but that's a huge help for this question right here, I think. And is there a question 5? We just did the whole project. I mean, we didn't do type 1, type 2 error, but we just did all the graphics, I think, in the project. So we did a lot of the project here. If anyone's in the chat and has questions, we'll go back and start talking about it. But in 1 hour, we've done a vast majority of the project and covered some pretty big topics on it. So I think this has been a very productive hour. So if you're watching this right now, go back and check the start of it, because we've covered a lot of the project and a lot of theory and understanding of what's going on. So we've got this company here, Nissan, obviously not a spoof on any real companies, but with this company, they build car engines. So they're thinking about getting new machinery. So what was type 1 and type 2? Oh, we'll go back and I'll do that right after this, Melissa. You got it. So it's the lamest of puns. But we've got here that they're thinking about getting new machinery to see if to build their engines. So you got to imagine this car plant, and they have these machines that make the engines, and they want to see if it would be a good investment. So you think about this, they test their engines to see if they catch fire. We could actually look at the data right here. This would be a good point for us to go in and actually look at the data. So let's go get the project data, which is right here. Click the project data, open the project data. Here's the project data. So if you look at this data right here, there's a few things going on. We've got if the machine was made on the new machine. So I know it sounds crazy, but we're talking about the engines right here. Was the engine made on a new machine, or was it made on a current machine? So we've got our current technology and we've got our new. Does that make sense in terms of what they're trying to do with the upgrade? Is they're saying, okay, we have this current way, this current machinery we're using, but now we might go to this new machinery. So they're thinking about investing $100,000 to buy the new machines. They currently have the current ones, and now they're going to get the new ones. They've got 2 metrics that they'll look at their machinery by. The 2 metrics they'll look at their machinery by is how long the engine lasts in terms of days. This is like, they make an estimate, like if they were to run the engine, how long until the engine would have problems. So this one right here lasted about 11 years. That's I would say that's pretty good. Maybe, I don't know. I mean, there's cars that last engines like 20, 30 years, but the engine apparently is estimated to have, and we could do the exact calculation on it. This first one, 4009.6 divided by 365, it has about 11 years on it. So that engine should get about 11 years. I mean, most of them are getting, you've got some variation. This one got a little bit less. This one got a little bit more. But overall, these engines are getting around 11 years, it looks like. That one's got a lot more, and that one got a lot less. I mean, 4,000 looks to be about average for these. We could figure that out. We could run the statistics on it. But now you see the engine goes through a safety check. And the engine is either going to be deemed safe or fail the safety check. And just think about this. Do you think the cars you buy, they check them before they send them out? Does anyone think here that when you buy a car, I mean, let's be positive and happy here, that the car has had some safety checks on it to make sure it meets certain standards? Like this will not, break or catch on fire or suddenly have an issue, that they're going to do safety checks. And I would think yes. So I would think that the car has some safety checks on it. So that's all they're doing right here is they're running a safety check on the engine. You got it, Melissa, 1,000,000 points right there. That I would think they're going to do a safety check on this. They're going to see if it passes or fails the safety check. I'd hope so too. So you can look at this and you can understand what's going on with this variable right here. This is not part of the project, but you can see that right now 15% of the engines have failed the safety check. Now what you'll find very quickly, I'm doing a little bit too much of the project maybe, I'm just going to do it for the heck of it, is, well, I don't think we do it this way. Yeah, we don't do it this way because it's not a mosaic plot. If we did do a mosaic plot, we could ask if the machinery explains the test results and take a look at what we have right here. What you'll notice is that the new machines are what? This is the last chapter. The new machines are what likely to fail than the old machines. I'm going to teach you the last chapter very quickly if you're watching this video. The new machines are what likely to fail than the current machines. Just look at the way the graphic looks right here. How does anyone think the new machines are what likely to fail than the current machines? And I will show you the easiest way to do the null alternative with this. Jake, you were right for 1,000,000 points. Jake jumps in and says less likely to fail. So we're going to go right here. We're going to grab this graphic. And guess what we're going to do? We talked about the null alternative earlier, which is something we hadn't learned yet for this chapter. But here it is. Here's the null alternative. And so let's bring this right here and go to a new page and see how to do this. Does everyone see it? This new chapter, which you haven't done yet, Melissa right there, 1,000,000 points, is x is independent of y, x is not independent of y. All you have to do is go between x and y, and truthfully it doesn't matter which order you say them in. We try to say x first, and you just have to say independent between them. So can anyone use this right here and tell me the null and the alternative for this new test, which I have not taught you yet in class? I'm trying to keep it on the same screen. There we go. Can anyone use the null and alternative that I have at the top of the screen to tell me what you would write if you were doing this as a test question? Who can do it? Who can do it? And I don't mind which order you do it in, because it might even sound better if you reverse it. I'm saying both in my head right now, and I'm like, and maybe the first way sounds better. Either way's fine. We'd accept either way on the test. So all you do, remember, just look at the x and y variable, look at what I've circled, and think about how up there at the top. And this is the only time we change the way we write it. And you just have to recognize this graphic right here and say, oh, this is where we use it. So just think about how you would turn that into a sentence, look at the x and the y variable, and just think about how you'd write this as a sentence right here. And I think the first time you do it, you'll be like, oh, that's how we do it. And I can do like 10 more of these really quickly, because you'll be like, okay, this is this of this. Who's got a guess? 10,000,000 points in the chat. Who's got it? You will have learned a major part of the next chapter. You'll know how to write the null and the alternative for the final chapter in the class. And it's the chi-squared test of independence. So you can just remember, oh, it's the chi-squared test of independence. I'll start you out. Machine. Careful, careful. Remember, only, and so Tracy, that would kind of work. Tracy, you're super close. Tracy, that would probably be acceptable. And so use these words right here. I like to use these. So the null is going to be what? You're super close, Tracy. 10,000,000 points. You still earned it. The null is going to have, look at where x is. X would be down here. So that's the x, and this is the y. And then just plug in the words between them to say, like, the machine is what of what? The machine is... So the machine is in... I know people are going to get it. I bet you got it, Tracy. The machine is... The machine is independent of what? And where's the y at? The machine is independent of the test results. Boom, you got it. You got it. Both got it. Both you got it. Tracy and Melissa, you earned 10,000,000 points right there. Great job. The machine is independent of test results. And Jake, you got it too. And then the alternative would be the machine is not independent of test result. And that does mean dependent. I mean, it's the same thing, tomato, tomato. That's why I'm like, I just like saying not independent, because it's either independent or not independent. They're complements of each other. But you just wrote the null and alternative for this right here. Let's do this one real quick. And I bet you can see. Watch this one. Watch. Here's another one. I want you guys to write the null and alternative for this. We have gender and we have broken bone. So what is the null and alternative for this test right here? We have gender and breaking a bone. Remember, just put your one word between the two of them. You want to go right here and put one word between them, or like is blank of the other. It'll be, you can just remember the words one word basically between them that you need to remember, since it's the chi-square test of independence. What would be the null and alternative for this? What would be the null and alternative for this? The null would be what? Gender is independent of breaking a bone. Boom. You just did it. That's the null. And then the alternative is gender is not independent of breaking a bone. Yeah, so it would kind of be that your gender kind of gives you information. Boom. Melissa, both of you get 1,000,000 points right there. Great job. And look at this right here. Who's more likely to break a bone? Males. And then when you go down here to the p-value, would you reject the null? And this is don't worry, this is the Fisher exact test. That's a whole nother test. We're not teaching that today. I just need to practice that. Yep, it's just practice. And that's why if we go to another one, I'll give the next one right here. So if we go and we do something like gender, and we do something like someone's order in their family. If you look here, these look very similar. And so this one's probably going to have a high p-value because it's very flat. In the last one, we will reject the null. This one right here, you'd reject the null because of the p-value here. But in this one, you would fail to reject the null with the p-value right here. Is there a video where you went over any chat? I think, did we do that yesterday? I think that was last week, Jordan. We could probably do that. And so Melissa has pointed out some good stuff. So Jordan, check out the video last week on Tuesday. And if you see some stuff, put some timestamps. I will say this. Tracy, you inspired me, Tracy. So here, Tracy, you inspired me. And I'll talk about that here because you'll like this, Tracy. And because people have really been working so hard at putting timestamps. Andrew put in a lot of timestamps too. But yesterday's video, if you go and look at yesterday's video, and right here, there's timestamps for everything. So we've got timestamps all across here on all the different things we were doing when different classes start. So you can literally click through and go to like a different question, and you'll just go right to that question right there. So thank you everyone who's like putting in timestamps. Andrew's been doing it, Tracy's been doing it, but you guys, I really appreciate that. And so right here. So reject, I believe it is above 0.5. So let's make sure we see right here. All the chapter 17 homework was awesome. You're welcome, Jordan. You're welcome. And if you don't see something in one of those videos, just ask and we'll do it. And I'm always here to help you guys. I appreciate that you guys are working so hard. So what we will do in the first one, let's talk about this test real briefly because we're basically teaching the next chapter now. What we'll do right here is we'll reject the null and say we have evidence that gender is not independent of breaking a bone. We will reject the null and say we have evidence that gender and breaking a bone are not independent. But here, and that's because of the p-value right here. We use the Pearson, excuse me. That's the p-value right here. We reject the null. Now, I know there's a lot of p-values. I'll tell you more about this next class. But this is the p-value we use, which means over here, we'll use the Pearson p-value right here. If you notice, the p-value is high here, so we'll let the null fly. So I would fail to reject the null that gender is independent of someone's birth order. So I don't have evidence that gender is not independent. That means that someone's gender really doesn't impact their birth order. Does that make sense? That somebody's gender does not impact their birth order. You do see that males are a little more likely to be a middle child, like me, but I don't think there's anything really going on here. All the differences are probably due to what? 10,000,000 points, and I mean it. All the differences here are just likely due to what? The differences we see between these two distributions are just likely due to this, because the p-value is high. The differences are randomness. You got it, Tracy. You got it. There are differences, but they're probably just due to random chance. They're probably just due to, boom, Melissa got the 10 million, awesome. Jake also, you guys know it. Logan got it right there. Are points working again now? I hope they are working. They weren't working at the start of the stream. Streamlabs, you got this. You can do it. I think sometimes at the start it doesn't work and then it boots up. So we'll see what Streamlabs does. These differences here are super unlikely by random chance because the p-value is so low. And let me see. So maybe points aren't working. Let me check in the background here on Streamlabs because I want it to work and I'm so bummed. Let me go to CloudBot. Really? Okay. Let me see if that literally did it. It literally, when I went to CloudBot, it turned on. So Tracy and I should see our points now. If that did turn on the CloudBot, and I do have to be here on CloudBot and have it turned on, then I see what's going on. I see how it works. When I went over to the screen with CloudBot, the thing went from on to off. Come on, CloudBot, you can do it. Now it might be booting up though, so we'll see what it does. It showed that it went from on to off when I went to that though. Let me check and make sure Streamlabs is still modded. So weirdly enough, somehow Streamlabs got unmodded. I don't know if YouTube's doing stuff like if YouTube doesn't like, I don't know, the point system or something. So I'm going to look through the video here. Okay, 2 seconds. Streamlabs is still a mod. Okay, we're good. And let's see if you guys are able to see your points now. Well, I'll keep looking into it. Would points carry over on Twitch? Yeah, they would. Well, no, you'd need the same name and stuff like that, Logan. Good question. That's the issue, is like if I go to Twitch, I've actually emailed the Twitch affiliate person, so I'm trying to find out information on Twitch and how to like what we should be doing and how it would work. And I'm super excited. It'd be super cool if we went to Twitch. So I want to give updates on that, and we'll see how that goes, because that would be a big jump. And so I'm kind of planning it out. And sorry, I don't know how I'm breaking Streamlabs. I'll make sure it's working next stream. That's why I didn't, once I understand completely why it works and why it doesn't work sometimes, then we'll be good to go. And I'm very sorry that the points are seemingly not working today. You know what I can do? I can go over here and I can give you guys points. Maybe that'll fix it. So let me go into the points and TW. I'm gonna give you guys 100 points right here. So TW, you now have 850. And Logan, let me bring up the chat here so I can see it. So Logan, let's give you another 100. If anyone's in chat and wants 100 points, just feel free to ask. I'll give 100 points to anyone who asks for 100 points right now. We're just having a little fun for the moment. So Jake, Andrew, Andrew. We should make Andrew. Well, no, we can't, because we have a few people who are really high up on the points. Oh, Andrew gave away some of his points last time. I gotta give Andrew a few more points. And there we go, Melissa right here. I got you, Melissa. Now, I wish it would show the points today. It shows that it's on. I'm running it through OBS. I'll have to look into it. So I think we just did it right there. And we'll see if it... I don't know why. I'm going to flip CloudBot on and off. Okay. Okay, now it's back on. I turned it on and off. I'm streaming through OBS, Streamlabs. As far as I know, everything should be working. So I don't know why I can't see my points. Let me try doing a poll, like see if a poll actually works. So here we go. Did it say a poll is started in chat? Let's see if it said that. Oh, you see, I can't even do polls right now, so something's off about Streamlabs. Maybe sometimes Streamlabs has problems. Jordan, let's give you some points here. Questions on the project or on the assignments. So Streamlabs is not showing my poll. So there's an issue. Something's... It says CloudBot is off. What are you doing, CloudBot? I turned CloudBot on. So, was it... So I just turned it on and off again. Who has project questions? Who has project questions? There we go. We updated Jordan's points. So let me try points again. I've turned it on and off like 2 or 3 times. Let's talk about the prompt again. I know, right? I don't know what's going on. Streamlabs is supposed to be working. It's supposed to be on. But can you go over the outro? Yeah. So let's talk. We'll finish up talking about the intro right here. Got a little sidetracked to sound a little fun. So with the intro right here, there's 3 things you have to cover. You have to cover 1, the problem they are encountering. So with the 3 things, we'll put a timestamp in here. The 3 things you should be talking about is like, what are they dealing with? And I went over that a little while ago now. But what are they dealing with? What is the problem that they're encountering? 2, you have to talk about pretty much the proposed solution and the data they have. So you need to talk about their data, the numbers. You can't write the intro or the executive summary without knowing the numbers from the report. The point of this is someone could literally read your executive summary and not read your report. I know that sounds counterintuitive, but an executive might just want to read your 1-page intro, which is your executive summary, and understand your whole report and the conclusions, which gets us to the 3rd part. You need to have what you should be doing, and you should really sell it. You shouldn't just say, so I think we should do this. You should say, like, the correct action for our company will be to do this based on the data that suggests blank, blank, blank. You know, I have a strong recommendation in this regard. You want to be firm with your words. You want to give the numbers. So think about this. Step 1, outline the problem for this scenario right here. What are they dealing with? Everything up there. I've got some stuff highlighted. What are they dealing with? Step 2, give the numbers you found throughout the report and try to say, you know, like, We did an investigation to see if the blank was more than the blank, which returned a result of us that this was this much more likely or this much more likely. Imagine if I told you, people in New York City right now, the coronavirus, oh gosh, fun topic, is 3 times higher than let's say, oh, it's way higher than Knoxville. But if I told you it's 10 times higher than Knoxville, you'd understand that. You'd be like, oh, it's 10 times more in New York City than it is in Knoxville. That's a very easy way to communicate a magnitude to somebody, to say, there we go, right there. You got it, Melissa. Great note in the chat. 1,000,000 points, Melissa, right there. So you would understand it. That's a part 2 part I'm saying right here. If I said the coronavirus outbreak right now is 10 times the magnitude in New York City. Sorry, New York, but you guys know I'm a New Yorker. So, or at least part. I'm more of a Tennessean now. I've been here like 20 years. So I guess if I finally earn my Tennessee status. But you would understand if I said it's 10 times the magnitude. You're just really communicating it very well to somebody. And then in part 3, you give the decisions you should be doing. You say, okay, and I definitely agree, Tracy. You say, here's what we should be doing. You should say, because of this, Tennessee should take these actions, so that we can blah, 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 blah. This is in our best interest for blah, 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 blah. So part 3 is like, what should we be doing? Part 1 would be like, the recent coronavirus outbreak has impacted many states in different degrees. Tennessee, luckily, is one of those that hasn't been impacted as much. At least I've been looking at the numbers. I think we're really good. Knox County is really good. Shelby, Davidson County, I think, are the highest. I watch way too much on these numbers, guys. You know me. I'm a numbers person, so this is all I look at. So Knox is like number 8 on the list. We're not at the very bottom, but we also have a decent sized population, so that has to kind of, got to balance those things. I wish it gave the per thousand. I wish everything was always in per thousand, especially for states. I mean, million per country, but you got to look at these things per thousand. People taking naps and doing schoolwork. I mean, what if we looked at places? I mean, then you have to look at, you're right, Tracy, you bring up so much stuff. This is what we would talk about in part number 2, like, this impact could be due to the fact that Knoxville is an education center. Like we have UT Knoxville, of course. We're also a major metropolitan area. We're not the biggest in Tennessee, though. You've got Nashville, Memphis, Chattanooga, Franklin. You've got all these other major cities. And then you have to look at all the other characteristics. This would be all part 2, where we're talking about all the differences. And then part 3 would be our suggestions. Like, to keep Knoxville on track with coronavirus, we suggest that people do this or this, and we take these precautionary actions, after we go through all the numbers we're seeing. Does that make sense? Part 1 is outlining the problem. Part 2 is giving the numbers, like, here's the percentages we see here, here's the percentages we see here. And then part 3 is, here's the suggestions I make. You have to be very firm, and you have to just make it sound like you're talking to someone. I can't say that enough. I've seen some outstanding outros and executive summaries, and the one I liked the most was somebody emailed me critiquing the project this semester, and they were like, I don't think this survey covered what it needed to cover. This survey should have asked this question, and this question. If our goal is to make this, then we should be focusing in on these characteristics. So we really this survey needs to be completely overhauled. And they were kind of like, being like, you're the boss, like, yeah, go there with just like gravitas and be like, here's what we need to do, here's what we should be doing, here's the numbers that back here's the problem we're encountering, here's what the numbers that back my decision, and here's my decision. Like, you won't say here's the numbers that back my decision when you're doing it, but you're giving the info that backs it. And I wrote that person back. I was like, this is amazing. I think they thought they were writing too critical of an email to me, because they were like, I hate to say this, but I don't think this survey is good. And I was like, yes, you're right, it's not good, because the survey wasn't written for the project. The survey was done, and then we created a project from it. So the intent, and they caught on to that, and I really appreciate that. So I told them, I was like, you should just translate this email into your outro, because you've done an amazing job. So what about that outro? Now, if you notice, when you go to the outro right here, it says your outro should clearly outline the data, the results, and the decision. There is a summary. The outro should focus on the importance of statistics making in data-driven decisions. Now, the reason this is here is because it's kind of an outro for the course. So when you think about this right here, you're kind of writing a unique outro. So you really need to tackle why we use statistics in data-driven decisions. I'm about to give you the full details on that. So let me go into why do we use statistics for data-driven decisions. It might be like a 5-minute talk right here. Statistics are a way. Someone's literally going to write this all down. We're going to see this as every outro now. Statistics are a way for us to not only visualize, but understand data better than we can by just looking at the numbers. There's no rules yet. Statistics are a way for us to visualize and understand data in a more comprehensive way than just looking at the numbers. With graphics and tests, we can create choices that are data-driven and not just based on somebody's intuition. So that's just my powerful sentences right there, because it's all about the graphics. It's all about the tests for me. If you guys know, I love my graphics, and I also love all the statistical tests. So, and I'm just trying, I don't want to write the whole thing. I don't want anyone to copy down exactly what I'm saying. They'll be like, yeah, we found this intro in like 20 people's reports. And be like, why did everyone write this same exact outro for their thing? But when somebody is trying to make choices by intuition, one, we often see these mistakes that are often based on like small sample sizes or differences that could be by random chance. But statistics is objective. This p-value over here, this p-value here down at the bottom, it doesn't care what you think about it. It's not statistically significant. That p-value right there, it's not statistically significant, and it won't be statistically significant no matter what you think about it. Now, you could cheat and make your alpha 0.8, but that's ridiculous. This p-value down here is statistically significant. And I didn't ask for it to do that. I didn't look at this graphic and said, man, I'd really like for these things to be statistically significant, this gap between the two, this discrepancy, as we call it in later classes, to be statistically significant. I just looked right here at the number and said, these differences I am observing between these two groups are unlikely by random chance. Yep. So don't copy down exactly what I say. Put it in your own words. But when you get something like a p-value is just based on math. And so math is only going to it's objective. Math is purely objective. There's no way to you could be like, well, someone could do the math wrong. Yes. But there's no way to cheat with the mathematics. You could just kind of get lucky and something could be possible by random chance. But what this number right here means is that the relationship I am seeing between these two variables will only occur about 1 in a billion times by random chance. So the differences we see between males and females breaking bones right here, this gap where males are more like, oh, that's not the males and females breaking bones. Well, this gap between the machines right here, do not copy, exactly. This is not the males and females breaking bones, but it's actually the project. So this is very good right here. This gap I see where the current machines fail 23% of the time and the new machines only fail 7% of the time. This difference of, let's go right here, 23, and here we'll just show the mathematics I'm doing. 23 minus 7.3. This gap of 15.7%, that's a gap right here of 15.7%, where the new machines have a 15.7% lower probability of failing than the current machines. This gap, if it's just random, like if this is just like, we got lucky with the new machines, it would only occur about 1 in a billion times. It would only occur about 1 in a billion times. You're saying, well, Brian, how are you finding that? You could take this p-value right here, which you can actually see it if you hover over it. You have to go to the output, and you have to hover over it. And it's got 708831. So we have to do, got to click over here. 8831. So it would only occur, I just said 1 in a billion, I was off. It's 1 in 11 million, 1 in 11.3 million. So this difference we observe up top, something as big as this difference or something as big or more extreme than this difference, I'm literally talking about the p-value, would only occur 1 in 11.3 million times by random chance. So if someone said, I don't know if that's really a difference, we'd say that difference is not likely to occur. And they would say, well, it's not that big. It's only 17.3%. Or what do we find? I think it was something like that, like 15%, 15.7%. They'd say it's just a difference of 15.7%. I'd say when we have a sample of 600 machines, this difference we observe here would only occur 1 in 11.3 million times by random chance. So do you think this difference occurred by random chance, or do you think we have evidence that this difference is not by random chance? Who thinks this difference is by random chance, or who thinks I think we have good evidence it's not by random chance? Now, we can't say it's not by random chance. We would just say we have good evidence it's not by random chance. And the evidence is the p-value. And when the p-value is low, we reject the null, which the null is that the two are independent. And this is why I love statistics, is because I'm not looking at that difference and being like, let me look at that visually and be like, yeah, that looks pretty big. I'm looking at it over here and I'm saying with the p-value, the p-value tells me that I would only see a difference as large or more extreme than this 1 out of 11.3 million times. And that was obtained by hovering over the p-value down here and then solving it out for the probability out of how many times it would occur. And so that is why we make data-driven decisions, is because data-driven decisions are objective. I think that's the biggest thing. Data-driven decisions are objective. You can give someone a p-value and it'll mean the same thing. But when someone looks at this graphic right here, which I said I know I love graphics, that's part of doing statistics is making graphics. But when someone looks at this graphic, they might think it's a big difference or not. Why is it allowed to say they are not random but still possesses? No. So great question. The machines we test should be random, but the differences we see were not random. Does that make sense? So we still took a random sample of machines. Great question, Tracy, right there. So the machines are still a random sample of machines, but the differences we observed between the current and the new machines were unlikely by random chance. We think that the differences are probably due to the new and the current machines. Does that make sense? We think that the differences are probably due to the machines being new or current. So I would think that the differences were not due to random chance, which we did collect random samples. But does that make sense? The differences observed between the machines on the new and the current were unlikely due to random chance. We did select random machines, and we're saying, I don't think it was the random machines we selected. I think it's actually the new and the current that is causing these differences. Cause is a strong word, but is associated, maybe I should say, because we never say something causes unless we can do an actual experiment. So this one is about as close as you can get to an experiment, because they're actually coming off certain machines. I was going to show one more thing right here. Let me give another big thing here, because I think we're getting towards the end, but I want to show other cool things. When you think about, like, let's do this right here. If we were to do this statistical test, which we don't even do in this class, this is for everyone who wants to learn a little bit of extra fun things for the moment. What would be your null hypothesis about all the means right here? If we were to test all the means right here, if you had all of these means being tested, what would be your null hypothesis about all of these means? Like if we looked at the high school GPA of only children, youngest children, people in the middle, and the oldest children, what would be your null hypothesis about all of these means? What would be a good idea for the nulls for all of these? What do you think you would maybe write out if you wrote out the null for only child, the null for youngest? Like if you wrote about all these means, does anyone have any idea what all the means would be if you just assumed something without any knowledge? You'd assume that all the means are what to each other? You'd assume, if you didn't know anything, actually, you know what, Tracy, 10 million points. You can say that. You can say that. You are totally right. You can do that trick right here also. And if it's independent, that means knowing somebody's family order would give you no information about their high school GPA. So that means their high school GPAs should all be what of each other? Yeah, we'll do that one next here, Paxton. Let's do that next. I'll hop off of this question in a moment. And Paxton, you got it. That's our next question on here. So they would all be equal, because if high school GPA is independent of family order, then knowing someone's high school GPA would mean that it doesn't matter. So they would all be equal. And look at this. Do you see the R squared? This means somebody's family order explains 0.05% of their high school GPA. Does that sound like family order explains a lot about someone's high school GPA, or basically nothing? So this right here, this R squared is so low, that means family order explains 0.05% of someone's high school GPA, which is basically nothing. And then look at the p-value right here. The p-value right here is so high that we would fail to reject the null, and we would conclude that we do not have evidence that these two are associated. When the p-value falls exactly on 0.5, Andrew probably knows something amazing for this. I'm going to show that really quickly, and then we're going to hop to Paxton's question, because I kind of want to show you the advanced cool stuff here. Now, in the advanced statistics, and I'll do this really quickly. I can do an example of this really quickly. So let's hop right here. And Andrew probably knows this very well. We're going to use the red class library really quickly. I'm going to pull up a data set of students, and we're going to see if somebody's, let's do handedness. Now, What variable are we going to use? We're going to use maybe GPA and gender. Okay, because we've been doing that earlier. So we're going to do associate GPA. I'm going to show you a trick here, Andrew. Watch this. Attach. Dr. Petrie doesn't like when I do this. So there we go. I attached it. GPA tilde gender. And that should do it. Too large. Okay. So Tracy asked, what if it's exactly 0.05? And so we've got these side-by-side box plots right here. We're doing a 2-sample test. And this is the really great thing is, and so I could make this, I'm going to show you this graphic real quick and then make the graphic. So we're looking at someone's GPA and their gender. We get the goodness of fit test. We get the permutation test, which Andrew probably knows pretty well. And then what you asked was, what if the p-value is exactly 0.05? Now, you might not believe this, but you know in our class how we make confidence intervals? Guess what you can make a confidence interval for? You can make a confidence interval for your p-value. So attach actually attaches it to the global environment so you can reach inside of it without doing the data equals, because you probably know you should write data equals survey 10. So you should do that usually, but when I attach it, it now makes it available without me going to the data frame. It attaches it to the global environment. And what about LM? Yep, you could use it for an LM also. So you could literally go here, L save into LM, and you could do height and weight now. And you don't need to attach it. You just have to watch out because you can mask things in the global environment. And we could literally visualize that model. And so with all of this right here, so you can do that right there, really cool trick. And so this goes back to Tracy's question. Then we're going to go to Paxton's question next. What if it's exactly 0.05? The really cool thing about advanced statistics is we can get a confidence interval for our p-value. So Andrew should know from his class that if 0.05 is in the interval, we would call that interval inconclusive because 0.05 is kind of an inconclusive value. So we would increase the permutations to see if we don't get 0.05 in the interval. But this is just me saying I'm 95% confident the p-value for the ANOVA test is contained in the interval 0 to 0.007. So take a look. I am 95% confident that the p-value for the ANOVA test is contained in the interval 0 to 0.007. So Andrew, is this interval right here conclusive or inconclusive for the p-value? Is that interval right there conclusive or inconclusive for the p-value? So is that a conclusive or inconclusive interval for the p-value? Would that be conclusive or inconclusive? Like, can we conclude something from this or not conclude something? Or Tracy, you could answer it too, and then we'll hop right to Pax. It's actually conclusive because in a conclusive interval will not have 0.05 in it. Because if it's 0.05, then we're like, I don't know, it's maybe significant or insignificant. So when it's conclusive, 0.05 is in the interval. When it's inconclusive, 0.05 is in the interval. When it's conclusive, which this interval is, it's either entirely below or an interval like this would be conclusive because it's entirely above. So this interval down here is conclusive, but this one also is conclusive because they don't contain 0.05. Because 0.05 is like when we don't know if it's statistically significant. So the answer is, what if our p-value is exactly 0.05? We'd make a confidence interval for it, or we would say it's inconclusive technically. Like it's kind of one of those values we don't like. We're like, it's kind of inconclusive. That's really not that good of a p-value. So let's hop to Paxton questions. I had a quiz count it wrong because it was 0.05. Oh no, ask me about those. My Pearson doesn't oftentimes do the really advanced stuff because it's intro to stats and they do the simpler versions of stuff. And so they might, I don't know, theoretically I might disagree with some of the things they write. I think there's like one or two things I've read on my Pearson. I'm like, we don't do it that way every time now. It's very small. And it's just because there's like modern statistics via computers. And then there's very classical statistics where we do it all the classic techniques, which you should know. Everyone should know both, especially if you're doing research and stuff like that. But computers and everything can do way better statistics now than we used to do by hand. Quiz 16. We're going to quiz 16 right here. We're doing Paxton's question. Thank you, Paxton, for hanging out. Hope you're still in the chat right here. I did the preview, so I need to not do preview. I need to do replace question. Replace question. Let's go here. Okay, so we got Paxton's question in the chat. Hey Brian, is there a video where you went over chapter 15 in Organization Monitors Education? Yes, I think it is last night's video. Let me show this really, really quickly right here, and then we'll find Paxton's. So if you go to last night's video, and I might be able to timestamp it and put it in the chat. So that'll really help right there. In last night's video, I have all the videos timestamped, all the things timestamped right here. So in organization monitors, right here. So we'll click this, then we'll copy the timestamp, we'll exit out of this. And so we should have, let me make sure I got the right timestamp on that. And I think we've done it. So let's drop this in the chat right here. And right there, Katie, that should bring you right to the video where I am talking about the question. So there you go. And if you look in the description, it has timestamps for other questions. Great questions, Katie, right there. You're welcome. Good to have you here. Swing by, say, hey, I'll try to get everyone. And thank you to Tracy, who inspired me to put all those timestamps in. And that makes it really helpful when we can just click it. And they're doing a new thing where you can do like a timeline on the video. So I'm really hoping that gets put onto our videos because you can actually like hover over it and see where everything's at. I still have the timestamps on it. How can mods do that? Put something in the comments. I'm going to try to take everyone's comments that I validate, and then I'm going to try to put those in the videos. So if you put a comment with a timestamp like, Brian covers this question, like right now in this video, basically an hour and 42 minutes in, we're going to go to the question that Paxton had. A company is sued for discrimination. There we go. So let's go do that one. A company is sued for discrimination. So here we go. Okay. So we've got a company being sued for discrimination right here. So we'll try to put a timestamp in and go where this question has gone over. So we have here is sued for discrimination because only 27% of their newly hired candidates were minorities when 57% of the applicants were minorities. Is this strong evidence that the company's hiring practices are discrimination? Completes parts A through F. So they want to know first if it's a one-tailed or two-tailed test. What do we mean by one-tailed or two-tailed? Well, in a one-tailed test, we would test either a greater than or we would test a less than. And a two-tailed test is going to be does not equals. So you would think of this. Do they want a does not equals test, a greater than, or a less than? If you notice the way this shades, the less than shades to the right, the greater than shades to the less than shades to the left, greater than shades to the right, and the does not equals shades kind of both ways. It shades both directions of it. What you have to do on the does not equals is you have to take where you landed and then do the absolute value on the other side of it. So it's like this would be, well, I guess we land at z, this would be absolute value of z right here. So you just do the kind of flip of it. So it'll always just be a mirror image of it. So when we look at this question right here, the company is being sued for discrimination. And since they're being sued for discrimination, they'd probably only want to show that they're hiring too few employees. So if you think about the test you're doing, it's probably going to be the less than test to say that they did not hire enough, that they hired too few. So my guess here, which it doesn't say, at least I don't think it says in the question, is that we'd probably be doing a less than one-tailed test. So the test is one-tailed because they wouldn't be sued if there was too many. So we're not trying to say it's not this amount. We're trying to say it's less than this amount. So they're doing a less than test. In context, what would a type 1 error be? So you have to think about a court trial right here. In a court trial, which they're at court right now, the null hypothesis would be not guilty. And I think Melissa was asking this earlier. So we have not guilty. And we have the alternative here, guilty. So let's think about this with our practice. Everyone should know in my class the following. 1, 2, A, B, plus, minus. So everyone got that? Hey, Carson, good to see you here. So we remember this right here. In a type 1 error, does everyone see the 1? In a type 1 error, the null is true. Does everyone see that? In a type 1 error, the null is true. And we reject it. You'll hear in a moment how it's easy to remember the second part. But you must repeat with me. You must pause the video and repeat with me. In a type 1 error, the null is true, and we reject it. In a type 2 error, the null is false. Do you see the F? And we fail to reject it. Do you see the second time I've said it? In a type 1 error, the null is true. That's a T right there. If you can't see, that's a T. In type 1 error, the null is true, and we reject it. In a type 2 error, the null is false. That's an F, and we fail to reject it. That's your second time saying an F. So you say 2 Fs. So we've got other notes over there on the side right now that a type 1 error is related to alpha. and a type 2 error is related to beta. I mean, it literally is your alpha and beta. Like type 1 error is your alpha, type 2 error is your beta. They're not complements, but they are related to each other. And a type 1 error I often call a false positive. It might not be in all instances, but I often associate it with a false positive. Like finding someone guilty when they're not would be a false positive. So you'll see that here in a moment. Because in a type 1 error, let's check. This is what you have to do, especially on the test. Let's practice. In a type 1 error, the null is true. So the null is true that this person is not guilty. It is true that they are not guilty, but I'm going to reject that, and I'm going to say that they are guilty. Do you see how I just figured out what the type 1 error is? I practiced it right here. I said, in a type 1, the null is true. It is true that they are not guilty. So this person is not guilty. That is true that they are not guilty. That is a true statement. But in the type 1 error, you reject the null, and you say you have evidence they are guilty. We can check our type 2 knowledge here by saying in a type 2, the null is false. And you always talk about the null. You won't say the alternative is true or false. You always say the null is true, the null is false. So in a type 2, the null is false. So it is false that this person is not guilty. If it is false that they are not guilty, they're actually guilty. But we are going to fail to reject the null. So I fail to reject that they are not guilty. So in this instance, a type 2 error is when the company is guilty, but we conclude that they are not guilty, or we fail to reject the null and can stay believing that they are not guilty. Does that make sense on how to do this right here and how to practice it? Knowing this right here, a type 1 error is related to alpha and all this good stuff. These are the big notes on this part. So hopefully that helps. Let's keep doing this problem right here and make sure we have all the answers. In a type 1 error, we said that it is true that the company is not guilty, but they're going to get said that they're discriminating. A type 1 error is deciding that the company is discriminating when they're not, and so that's one of the errors there. In this context, what is a type 2 error? In a type 2 error, the null was false, so the company is guilty of discrimination when they're actually not. So in a type 1, let's double check. I think it's reverse, Tracy. I think it's reverse. In a type 1 error, the null is true, but we reject it. So if the null is true in a type 1, and it'll always change for situations. And this is a big thing I should say. I hope I made this clear enough throughout class, that you have to look at the situation because sometimes the type 1 is worse, sometimes the type 2 is worse. So in the type 1 right here, the null is true. The company is not guilty. In a type 1, the null is true. The company is not guilty. But we're going to say they are guilty. In a type 2, the null is false. It is false that the company is not guilty, so they are guilty. But we're going to say they're not guilty because we're going to fail to reject. Remember, in a type 2, you fail to reject the null. So all that good stuff right here. So in a type, wait, it's type 1. Okay, I scrolled back up. I thought, because I was like, I'm not doing type 2. In a type 2, it is false that they're not discriminating. So in a type 2, it's false that they're not. So the company is discriminating. No, it's decided that the company is not discriminating because we're going to fail to reject that when it actually is. Okay, good. I think we got it. So in a type 2, remember, it is false that they're not discriminating. So they actually are discriminating. So it is actually discriminating, but we're going to fail to reject the null. So it is decided that they are not discriminating. We're going to decide. It's so much crazy, right? It's very easy to mix up. What is the power of the statistical test? Let's see. The power of the statistical test is the ability to reject the false null. So power is the formula. Let's write it down. Power is literally everything not making a type 2 error. It's 1 minus beta is power. So the equation for power is literally not making a type 2 error. And power is said in statistical words, the ability to correctly reject the false null. And so what do we not want to do? We don't want to make type 2 errors. This right here is a type 2 error. So power is not making a type 2 error because it's everything but making a type 2 error. And so let's check that out. Let's see if we have an answer that lines up with being able to detect that the company is discriminating when they actually are, something like that. The power of the ability is the ability to correctly. I see a correctly right there, and I like that because power, by statistical definition, is the ability to correctly reject the false null. Correctly detect actually discriminating. Yeah. So if they're actually discriminating, that would mean the null is false. So if a company is actually discriminating and we're able to detect that, we're able to reject the false null. Because think about this. Once again, if the company is actually discriminating, they would be what? They would be guilty, which would mean the null is false. So that means if we can detect that they're guilty, we'd be able to correctly reject the false null. So that seems in line with what we should have right here. I like the correctly, that clued me in on it, knowing the definition that it's the ability to correctly reject the false null. And then we have the other one that says correctly determine it's not discriminating. It's about rejecting the false null. So this would be retaining the null or failing to reject the null. So that's not the definition. If the hypothesis is tested at 10% level of significance instead of 1, how would this affect the power of the test? I have gotten this one wrong, but I know how to do it. This is the one I always like. I'm always like, no. So if I get one wrong, it's going to be this one. Okay, so let's look at this. We've got our alpha level right here. The 10% is our alpha level, and this is the 1%, which is going to be our new alpha level. So our alpha level is going to, just the way they word this one always gets me. Like, are they saying we are decreasing our alpha level? So when you decrease your alpha level, how will this impact the power of the test? We got to do a quick review on this. So this means I'll get it right if I do the quick review. There are 3 things that impact power. The 3 things that impact power are your sample size, your alpha level, and your effect size. Now, these all, when you impact beta with them, I know I said power, but when these go up, beta goes down. But why am I talking about beta? Do you remember what we just said about beta a moment ago? Beta is going to be 1, or 1 minus beta is power. So when we think about what happens if beta goes down, power goes up. So we have this relationship right here between all of this. That if you increase sample size, what will happen to power? So if you follow this pattern, that if any of these go up, beta goes down. Now it's true if they go down, beta goes up. But so they're all inversely related. But what happens if sample size goes up? I think you might be saying it. If sample size goes up, power will go up because beta will go down. Because remember, power is just 1 minus beta. So right here, every time beta goes down, power goes up because it's just the complement of beta. It's like if beta goes down to 0.03, power goes up to 0.97. So if you notice, when alpha goes down, what must power do? If alpha, that's interesting. Well, yeah, let me think here. If alpha goes up, okay, cool. My brain just flipped for a second. Because if alpha goes up, you're able to reject more often and able to reject the false null. Everything is correct. My brain just changed. So when you think about this, alpha went down in our problem. So alpha decreased. So since alpha decreased, beta would go up. And if beta goes up, power goes down. So the power of the test should be lower. I'm so worried on this question. It all makes sense theoretically, and then the way they word it just gets me every time. So let's make sure. Let's try it. Okay. So the hypothesis test is tested at 10%, and the level of significance... Oh, wait. So if the hypothesis test is tested at 10% instead of 1%, that's what gets me on the wording. So is alpha going up or down right here? It's tested at 10% instead of 1%. Is alpha going up or down? It's tested at 10% instead of 1%. The number is lower or the strength is lower. The sample size. The sample size. If the sample size gets smaller, the power gets smaller. If that makes sense there, Tracy, and I can check back. But since we're testing at 10% instead of 1%, alpha has now gone up. So the power of the test should increase because the significance level increased. So let's check this. So if you look at the way this has to go, is that if alpha goes up, power goes up. I think it's going to be C. I think, Carson, you're right. Great job, Carson. Because alpha went up, we went from an alpha of 0.01 to an alpha of 0.10. And it's behind me, of course. But we did this right here. We went from alpha of 0.01. So good to see everyone. What's up, Connor? Alpha is type 1 error. We got our 1, 2, A, B, plus, minus. And we can put the A, B in there as alpha and beta. So we've got the alpha and the beta right there. And then we've got the plus, minus. And then we go from an alpha equal to 0.01. Let's do it again from the start. Oh, no. I'm losing it. The hot lights, I can't blame them anymore because I adjusted my lights. Equals 0.01, and it's going up to alpha of 0.10. It's blocking me. Nope, we're not blocking me. Good. So if you look at this, the alpha's gone up, which means the beta goes down, and the power goes up. So we should have it. We spent a long time on this one. We should get it. And last but not least, we did this one earlier. Connor and I did this one. The lawsuit is based on hiring 55. Oh, no, we didn't do this one. We did a different one. It's based on hiring 55 employees. Is the power of the test higher, lower than, or the same as if it was based on 186? So you have to be careful. It's saying compare 55 to 186. So let's go look at our cheat sheet here for power. So now we have to put at the bottom here that it's based on 55. So how does 55 compare to 56? So we're saying, or 55 to 186, we're saying, how does it compare? Just chill with Brian. I like it. Let me make sure I've read it correctly. The lawsuit is based on 55 because of this. And the lawsuit is based on 55. Is the power of the test higher, lower than, or the same as if it would be if it was based on this? So is 55 a weaker test or stronger test than 186? And it's definitely not the same because we're changing the sample size right here. So it's definitely not the same. So let's compare 55 to 186. Power goes down because sample size went down. So beta would go up and power would go down. So because the sample size is smaller, the power test would be lower because the sample, and it is saying sample size decreases. So no matter what it is, sample size has decreased, so the power would be lower. Let's make sure I didn't click a wrong question. I think we didn't. We got 100%. Of course we did. It's so easy to change the wording or like, wait a minute, did it go down? But always have your cheat sheets out and understand what stuff like this means. These are the big things right here. Paxton, did that make sense? Did you get it right, Paxton? Watch out on the wording. It'll trick you. It almost got me once or twice, but knowing the wording and knowing the cheat sheet stuff is very important right here. Like if you have this cheat sheet to show you that if sample size goes up, beta goes down, power goes up. If alpha goes up, beta goes down, power goes up. If effect size goes up, beta goes down, power goes up. And what are these things? If you're watching the video and you're wondering what is sample size, this would be like if you were to watch me play a basketball game against my brother for 5 minutes or an hour, it'd be easier to figure it out. Yes. Mine was a little different, but it made sense. Awesome. So I'd be watching the game longer. Alpha is how much you would say I have to beat my brother by for you to say I win the game. So you could increase it and it'd be harder for me to win, or you could decrease it and it'd be easier for me to win. That one's a little bit different on how it works because the alpha is a little bit different. Like if you were to have a higher alpha level, you would be more willing to reject the null. So you would only require me to beat him by 1 point. For question 3 on project 3, how do we convert the average days 360 to a decimal for the p-value to write our hypothesis? Emily Pope, let's do that next. An effect size would be how much better my brother is than me. A bigger effect size would be if I played, what is his name, Dwight Howard, or if I played my brother, there'd be a bigger effect between Dwight Howard, and it'd be easier to see that he's better than me, so he'd be more able to reject the null. Let's hop back to the project here for question 3, part, what again is it? Question 3 on project 3. Are you asking about this right here? Emily, are you asking about this number right here on the project? So this is the one you're going to test. You won't have to convert it to a decimal. What you'll do is you'll go to the output, and so I'm kind of doing it a separate way right here. I'm doing it on a separate question. You'll go when you have the output up, and you'll go here to test mean. This is a totally different output. And then you'll put in that hypothesized value, and then it'll test that value for you up here. So this is where we can test a value, and it'll do the equation you can see right here in the corner, where this is the mu naught. So mu naught is whatever the hypothesized value is. So this is mu naught right here, and then it'll do the y bar, which you can see this is y bar, and this one. But does that make sense right there, Emily? Is that this is going to be mu naught right here. So this is the mu naught. You won't have to change it to a decimal. It'll just be what you put in when you do your test. And I have totally different output in mind, so make sure to watch the start of the video or ask any question you have right now if you're stuck on it or if your output looks weird or anything like that. Any question you have, feel free to ask. I think, Connor, are you working from 3 to 8 today? So good to see you here, Connor. Do we use that number for part C question? Let's look at part C. Yes, you do. Definitely. You will use that number for part C, that number right here, if we take a look at what it is. And we did a review of this earlier. Don't write, this is not the answer to part C. It's kind of the whole, everything you'll be doing for this whole class with nulls and alternatives. If you look at this right here, this is mu naught. And if you see, we've got some tips on what to write. Here's some tips on how to use this. But awesome job. So Connor will be helping out from 3 to 8 today. So if you look, we've got some tips on what to write right here. Does this make sense, Emily? That if I've identified 3,600 as mu naught, whatever's good with you. I mean, yeah, just, keep it open, keep working. Hopefully, if 2 to 8 works, we could do that. I'm sure students would like that, and I'll send out a reminder that you're helping out. Hopefully you don't have like 100 students in there. It'd be crazy. But, and I imagine it'll get busier. So just send me an email with which one you want, or remind me here in chat. And so, does this make sense, Emily? Do you have an idea of what to write for this problem? I know there's a lot of output on the screen right now, but I really have all 3 ways of writing the nulls and alternatives with what we currently know on the screen. With when you use p, you'll use p naught. When you use mu, you'll use mu naught on the other side. When you use mu1 minus mu0, the tested value will be 0. So p is not, no, this is mu naught right here, because this is the tested engine life amount. So this would be mu naught. Because we're testing the mean, all of this stuff right here, the true mean is mu, which we don't know the true mean, but that would be mu. And then from our results, which these are not the results up here, these are not the results you'll be getting, but up here at the top of this, you will get a y bar. So that's y bar right there. Awesome. Does that? Yep. And does this make sense here, Emily, that this is all mu naught and y bar, because all of these are means? Yeah, great question, Emily. Feel free to, you're welcome. And so what Jump will do in the background, and feel free to ask anything, be like, how do I do this? What's up with this question? It's doing this equation in the background when it solves the mean. The previous question, so if you look, this one is testing the mean right here. So this is all, we're testing the mean, and the tested value of the mean is mu naught, and the sample mean is y bar. And then the previous question, so these are great questions, because in the previous question we were doing proportions. So in the previous one, when you're doing proportions and you've got confidence intervals, you'll have a p hat, and you're trying to find p. I can start at 2:30. I have to eat after class. Cool. Awesome. And we'll see if anyone else has any other questions. Feel free to ask. There's lots of great stuff throughout this video right now. So we did most of the project, Emily. If you want to check back on the start of the video, or if you have questions right now, feel free to ask. I might head off here in a moment. But I got the Batman shirt on today. But so good to have everybody and all that. How is StatLab set up? You come in, you ask questions. We're going to play some pool. I'm horrible at pool. I taught my fiance how to play pool. And I shouldn't say I'm horrible. I'm decent. But she's such a fast learner and so good at pool. I only beat her the first game, and then she beat me the next 2. And she was really good. In the second game, it was close. And then the third game, she was like, so if I want to bounce it off the corner 2 times and hit this ball that combos into this, can I do that? I was like, yeah. And she's like, bink. And I was like, and you just did that. And you just did that. And she's really good at ping pong too. I think she'd approve if I said we're evenly matched on ping pong. We might be evenly matched on pool. And I've played it my whole life. She's played it 1 time, and she's good at frisbee too. So all that good stuff right here. When we can go outside again, I'll see you outside, Andrew, sometime, I'm sure. But yeah, she's a fast learner, and that's always one thing I've loved about her, is how fast she can learn stuff and how well she learns it. She'd blush if I knew she's talking about her so much, but anytime she has to learn a new skill, she's just so quick at it and so proficient at it. And I'm just like, how did you learn how to play? She was like, I have such a great teacher at pool. And I was like, well, thank you, but you're so good at it. But it was so much fun. I liked the really close games. It was just fun teaching her, and then it was fun to have close games. So it's like, holy mackerel, you're able to beat me at pool now. But yeah. I know, I said that. I made that joke. I was like, do you want to put bets on this now? Is that what we're going to do? And she was like laughing. She's like, played pool her whole life. Just yeah. But she made some really impressive shots. I think there was one where she hit 2 walls and then knocked a ball into another ball to get it in. She's like, okay, so I bounce here, then hit this one and go in. You can do that. And I was like, yeah. She just does it. And I'm like, there you go. You've done it. And so, yeah, it was really good. I think we played 3. We might have played 4 games. If we played 4 games, she beat me 3 out of 4. If we only played 3, she beat me 2 out of 3. But I know she definitely had more games won. So, but it was a lot of fun. So I missed that. I just want to go to Oklahoma and just play pool. So it's like, if I just throw the orange ball into the basket way over there, dunk. Oh, did I do that? Did I do that during class? I feel like I feel like that's something I said, and then it happened this semester. I was like, oh no, I feel like I feel like there was something I said, like, I feel like it happened during office hours or something. I was like, what if I just like make this shine, just like tossed it in, or I just like it was like way across the room and it's kind of cool. Something like that happened. There's always those crazy things. Awesome. You throw better left-handed. My left hand is useless. I mean, I still need it, but and you're right-handed. That's awesome. No, I'm so I can't. Left hand just it plays chords on the piano. That's what it does for me. It plays chords, and that's it. Well, this video has a lot of great stuff in it. We got a lot of the project done. We talked over all of it. We did a homework assignment, and so we've got a lot of great stuff in here. We'll head out, and I'll see everybody later. Like the video, subscribe, everything, do all the great stuff. We'll figure out the Twitch stuff, and maybe some fun stuff. You two have a great afternoon. It's good seeing you, Tracy, Andrew, Emily, and everyone else that we had in the chat. So good seeing everybody. I will see you guys tomorrow.